Hello and welcome back to the module 4 of the CAMS, and again we are solving some of the numericals. Okay, so today we will solve numerical number 8. I'll read the problem. A flat-faced mushroom follower is raised to a distance of 25 mm in 120-degree rotation of the cam, remains at rest for the next 30 degrees and is lowered during further 120 rotation of the cam. The raising of the follower takes place with cycloidal motion and the lowering with uniform acceleration and deceleration. However, uniform acceleration is 2 by 3 of the uniform deceleration. The least radius of the cam is 25 mm. Draw the cam profile and also determine its maximum velocity and acceleration if the cam rotates at 240 rpm. Okay. So when we look at the question, we know that this is a flat face inline follower because nothing has given about the offset, so I can assume that this is an inline follower. Also from the question I can deduct that the stroke distance is 25 mm, okay, and angle of rise is 120 degree, okay, and the dwell is 30 degree, and also angle of fall is 120 degree. Now dwell 2 they have not directly given, as I told you, in many times they won't give, but you can always calculate because the sum of angles of all the 4 angles is equal to 360. Here we know that angle of rise is 120, dwell 30, and angle of fall is 120. So the addition of all three angle is equal to 270 degree. Hence 360 minus 270 degree will give me 90 degree second dwell. Okay, so I can calculate this, no problem. Okay, so now when next step is to draw the displacement diagram. But we know that here the angle of rise, it follows cycloidal motion. Okay, we have not discussed it before, so I'll just give a brief about how the cycloidal motion displacement diagram is drawn. Okay, so in this case, in this particular example, the angle of rise and fall, they both follow the cycloidal motion in this example. Okay, if you see here, right here, the way to draw is the same. First you divide the angle of rise and angle of fall into 6 equal parts, okay, and draw the vertical lines. That is the same for all. Next, to get the points 1 2 3 4 5 6 with the dash, okay, for that you are supposed to draw here a circle, okay, a circle at this, from this corner, okay, with the radius equal to s by 2 pi. Okay, so this s is nothing but the stroke length. In our case, the stroke length is 25 mm. So whatever the stroke length is given, in that divided by the 2 pi will give you the radius. So with that radius, you're supposed to draw a circle from the center here, and then divide the circle into 8 equal parts, okay, to get the point 1 2 3 4 5 and 6. Okay, you're going to 6 right here, and then B is already got because that's the center. Now you draw a horizontal line from 1 to 2 to get A, and then 4 to 5 to get C. So you are supposed to get these points A, B, and C. Okay, so once you get these 3 points, then from point B here, or from the center point, draw a line to the other end, the diagonal line to the other end, okay, to get 6 dash. Similarly, from point A, draw a line parallel to the first line to cut 1 and vertical and 1 and 2 to get 1 dash and 2 dash. Similarly, from point C, draw another line parallel to this original diagonal line, so that to cut 4 vertical and 4 and 5 to get 5 dash, 4 dash and 5 dash. The same thing has to be repeated on the angle of fall portion also. Okay, so in our problem, the stroke is 25 mm, angle of rise 120, dwell 30, angle of fall 120, and dwell 90 degree, which is shown over here. Okay, which is shown over here. Okay, and then the stroke length is 25 mm, that is also dropped. Now let us concentrate on the angle of rise, okay, which follows the cycloidal motion. I'm going to first draw this. Okay, so first we are going to see how to draw the displacement diagram for the angle of rise portion, which is cycloidal. Okay, now in cycloidal you have to first calculate. You're supposed to draw a circle at this particular corner. Okay, so the radius of that is given by s by 2 pi, where s is the stroke length of this particular problem, which is 25 mm, divided by 2 into pi gives me 3.97 mm. So with radius equal to 3.97 and the center over here, I'm supposed to draw this circle. Now yes, it is difficult to get 3.97 and all, so you can just draw a circle of radius 4 mm. Okay. Now for to draw these such small circles, the pro circle instrument will be very handy. So if you get that, please keep it with you. Okay. So once you draw the circle, divide it into 8 equal parts of a 45 degrees each. Okay, and then once you draw the two diagonals, join a line as a horizontal line from this point to this point to cut the vertical line over here. Okay, similarly, draw another horizontal line in the, from this particular point to this point to cut the horizontal line this at this particular center point. Okay, so because we are interested in these 3 points, the one center line, the line one above that, and one point below that. Okay, then from the middle center point or center of the circle, draw a diagonal line to the opposite end. Okay, to the opposite end, so that to the end 6 dash. Now when this line where it cuts the vertical line 3, that is the 3 dash. Similarly, draw a line from the point below the center line. Draw a line. Now this line is parallel to the original, the first line, the first diagonal line that we drew. Okay, so that is the reference. So this line is parallel to this line. Okay, so when that line cuts the vertical line 1 and 2, name it as 1 dash and 2 dash. Similarly, from this particular point, the above point, draw another line parallel to these two lines to cut the vertical line 4 and 5 and get 4 dash and 5 dash. So this is how you get these points of interest: 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash in case of cycloidal motion. Okay. Now the next portion is the angle of fall portion. Now this angle of fall portion, which is 120 degree, it follows UARM. But in the question what the suggestion was, acceleration is 2 by 3 of the deceleration. In that case, I have to first divide this 120 degree into 5 equal parts. Now how did I get 5? 5 means this 2 plus 3. 2 plus 3 is equal to 5. So hence I have to divide 120 into 5 equal parts. So when I divide 120 divided by 5, I'll get 24. Okay, 24 degrees. In that 24 degrees, 3 parts are for acceleration and 2 parts is for deceleration. So that is how I got this 72 and 48. Okay, so 120 degree is divided into 5. In that 5, 3 parts is for acceleration and 2 parts, okay, is for deceleration. So 24 into 3 is 72 degrees, and then 24 into 2 is 48 degrees. Okay, so here it is, divide 120 degree into 72 and 48. Okay, now after doing that, all right, now we also know that this 120 degree is usually divided into 6 equal parts, right? So this also we have to divide such that 72 degrees divided by 3 and then 48 degree divided by 3. Okay, so this 72 degree divided by 3 gives me 24 degrees each. So when I put it in the scale, okay, so this distance should be equal to 24. Now since I have taken a scale of 2 mm is equal to 1 degree, then in this case, sorry, okay, in this case 12 mm, okay, the distance between them is 12 mm, 12 mm and 12 mm each, okay, which represents 24 degrees. Similarly, 48 degree divided by 3 is 16 degrees each, or the distance between these two lines is 8 mm each. So this is how you divide it. Okay, so once you divide the angle portion, the same has to also divide in the vertical line 3 in the same fashion. Okay, again the total length is 25. That 25 has to be divided by 5. Why 5? Because this 2 plus 3 is equal to 5. Then out of, okay, so 25 by 5 will give me 5 mm. In that 5 mm, okay, 5 mm into 3, so 15 will go to the acceleration part, and 5 into 2, 10 will come to the deceleration part. Similarly, this 15 has to be divided into 3 parts, then 5 mm each, and then again this 10 mm has to be divided by 3 parts, which is 3.33 mm each. Okay, if it were uniform, then what we would have just divided 25 by 6, isn't it? But now you have to divide this into 3 portion and 2 portion, and then divide each by 3 and 3. Okay, so after you draw divide the angles into 6 parts, not equal but in their order, and also this vertical into 6 parts, then you complete the UARM. Okay, how is that? So from this top corner, draw a line to get 3 dash. From here to draw the line to this particular point to get 4 dash, 5 dash, similarly 2 dash, 1 dash and 0. Okay, so this is how we get for the uniform acceleration when they are not equal, okay, but with some ratio. So you add this ratio, and that is where have you get it. Okay. Alright. So next you complete the displacement diagram. Once I get that, I'll then go to draw the cam profile. Okay. So it's a flat face follower. Base radius we know is 25 mm. So I'm going to draw that circle. I'm going to mark this as O, and then I'm going to draw a flat face follower. Okay. Once I do that, okay, so this is O. Then I'll draw the angle of rise, which is 120, 12, 30. Then angle of fall, which is 120 degree, and then again 12. Okay. But this 120 degree is again 72 and 48. Okay, how did I get these values? I got it from the displacement diagram. Okay, so this 72 plus 48 will again become 120. Okay, now the next step is usually to divide the angle of lift and angle of fall into 6 equal parts, correct? Okay, so now first let's go to the angle of lift. Angle of lift is completely 120. 120 by 6 is 20 degrees each. Okay, so I can divide that. 20 degrees each. But when you come to the angle of fall, you have to divide that 72 degree into 3 parts and then 48 into 3 parts. Okay, so that's the difference. Okay, you have to divide this 72 into by 3 parts and 48 into 3 parts, just like how we did it in the displacement diagram. So when you do that, okay, so this 1, 2, 3, 4, 5, 6 is all equally divided. That means the angle between each is 20 degree. But when then 30 degrees is the 12. But here 72 divided by 3, okay, that is equal to 24 degrees each. Okay, here 24 degrees, and then this 48. Okay, 48 by 3 is 16 degrees each. Okay, that is how I got 6, 5, 4, 3, 2, 1 and 0. Okay, once you identify those points, then what you're supposed to draw the extended lines, isn't it? Okay, once you draw the extended line, then you transfer the length from the displacement diagram to here to get 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, then again 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and also 0. Okay, so this is how you transfer the points. Alright, once you do that, then because it's a flat face follower, at each of those points, 1 dash draw a perpendicular line, okay, or normal to that line. At 2 dash draw a perpendicular line, 3 dash a perpendicular line, 4 dash it's here, 4 dash is perpendicular line, okay, 5 dash, 6 dash, then similarly the same, let's see here 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and also 0. Okay, suppose you draw the perpendicular lines. Once you draw that, then you draw the curve, okay, tangent to all these flat lines, okay, and complete the profile of the cam. Okay, so this is how you are supposed to get the solution. All right, so this is actually taken from the book, the same solution. Okay, you see how the tangent is drawn. Tangent is drawn perpendicular to those perpendicular lines, how the tangent of a curve cam is drawn. Okay, so hope you understood how to draw this. Again, as I told you, the thing that we learned in this is there is a cycloidal motion, and then in uniform acceleration retardation also there is separately. Okay, so you have to divide the angles separately and then you have to get it. Okay, after that follows the maximum velocity and maximum acceleration. So speed is given to 40 rpm, stroke is 25 mm, which is 0.025 meter, angular velocity 2 pi n by 60. So substituted n over here and got the answer as 25.13. Okay, now here the lift of the motion follows cycloidal, hence the formulas I have. This I have taken it from the chart, so I have to memorize it. And then for the fall it is UARM. Again the formulas I have to memorize and keep it. Okay. Then angle of rise, uh, theta r is 120 degree, but we want it in radians. So get that value and then substitute it on the equations. 2 omega s by theta. Here theta is angle of rise theta. Okay, so get substitute that and get the answer. Okay, similarly for the angle of fall also, which follows the UARM. Okay, again the degree is the same, 120 degree, and substitute their formulas and get the answer. So maximum velocity will get as 0.6 meter per second and acceleration as 14.45 meter per second square. Okay, so you know that you're supposed to do all these problems in your notes and copy it in your notes and maintain a notes. Okay, and I'm gonna give this numerical 8 as an assignment. All right, I hope you understood. Have a good day.